So now that we know the order that the electrons fill, and you can see that I put it on the board above me, and I'm going to leave it up here for the remainder of the chapter because we're going to need this for reference. I really encourage you to write it down on your own papers and make sure that you also have the order that the orbitals fill, whether that's using the diagonal method, using the periodic table to help you, which I'll teach you in a moment, or just straight memorizing it, whatever you're going to do to know the order that the orbitals fill. We're now going to add another piece to that puzzle, and that is looking at how many electrons can be in each orbital. And I think you remember that each orbital can hold 2 electrons. So this is my s orbital over here. I have another s orbital over here. If this is n equals 1, this might be n equals 2, right? They're going to be increasing in size, but each orbital can hold 2 electrons. So the s sublevel has only one possible orientation. Remember that? The s sublevel has just the one orientation, and so it can hold a max number of 2 electrons. So because my s orbital has only one possible orientation, it can hold 2 electrons. And before I fill in the rest of this chart, I want you to think this through with me. How many orientations did P have? Do you remember? Look back. P has 3 possible orientations. We're going to count these by odd numbers. 1, 3, D has 5, 7, 9, and 11 possible orientations in S, P, D, F, G, and H. Then if we want to figure out how many electrons they have, just 2 per orientation. So P, because it has 3 possible orientations, can have a total of 6 electrons. D, with 5 orientations, can have 10 electrons. F, with 7, has 14 electrons. G, with 9, has 18 electrons. And H, with 11, has 22 electrons. So instead of having to memorize how many electrons are in the G sublevel, instead you can use your logic, you can use your reason. S, P, D, F, G, H counts odd, 1, 3, 5, 7, 9, 11, multiply by 2, and you have the number of electrons that they have in each of their sublevels. So now we can open up this chart. It's going to look exactly like the one I have on the board, but I think there's something really powerful in actually doing the math yourself and seeing that this is not a big list of things we're memorizing. This is a series of things that build upon one another. If you understand one thing, or you memorize just simply S, P, D, F, G, H, you know that it's counting by odd numbers. We can really we can extrapolate the number of electrons every time without having to memorize it. Personally, not big into memorization. I much prefer this kind of a scenario. So putting all of this together into a picture of what our quantum model of the atom starts to look like, we're going to start with a nucleus in the center of the atom, as we know. And we know that the first sublevel that would fill up would be 1s. And we know that S, principal energy level 1, has 1 s orbital and a total number of 2 electrons in it. So I'm going to put my s orbital drawn as a circle with 2 electrons at opposite poles of that circle. Following 1s, the next orbital that would fill would be the 2s orbital, and that 2s orbital would also have 2 electrons in it and be spherical in shape. The difference is that if this is n equals 1, then n equals 2 is going to be just a little bit bigger. 2 electrons in our n equals 2 here at the opposite sides. Now we start to get a little bit more fun because the next orbital that fills is going to be a p orbital, and it's going to have 3 possible orientations. 1, 2, 3. So this is still n equals 2 out here, and it has our s and our p orbitals. What we fill after that is our 3s orbital, which is a circle, a sphere, that covers all of these guys with 2 electrons in there. And then we have our 3p orbitals, 3p here. 1, 2, 3 p orbitals filling, and then we get to our 4s. And then we have to do our 3ds. Those are those 4-leaf clovers. I'll try it. That's 1, 2, 3, 4, and then remember the last one was up and it had that ring around the side. And we're just here. We're not very far through our periodic table. And so you can see that drawing an atom like this is really not going to work, right? If I were to ask you to draw an atom on the test and you were supposed to give me that, that's not going to work. We need to come up with a nice, neat way to represent the number of electrons in the atom. And that's where orbital diagrams and electron configurations are going to enter, and we're going to give us a way to nice and tidy, organized, draw out all of the electrons that are in our atom. This is why we call it the electron cloud, but that's not how we want to show it on our paper. So when we start up again, we'll be working on a neater, nicer, tidier way of drawing this crazy quantum model of the atom.